This is question 2 from A2physics 5 It's a question on magnetic fields. State Faraday's law of electromagnetic induction. So Faraday's law is that the magnitude of the induced EMF is directly proportional to the rate of change of flux. Part B. Lenz's law is sometimes thought of being simply a statement of the law of conservation of energy. Consider the introduction of a magnet into a coil which has been connected to a resistor as shown in figure 2.1. Explain how Lenz's law and the conservation law are related in this example. Make reference to Faraday's law, Lenz's law, the work done in pushing the magnet towards the coil, and the thermal energy generated in the resistor. You can see there's four marks there down at the bottom. So those four things are what they're going to go on. So make reference to Faraday's law, Lenz's law, work done, and the thermal energy. Those are the four things that you have to get into your answer. So first thing there then that we're going to say is something about moving the magnet towards the coil causes a change in flux linkage. In the coil and induces an EMF. Now you have to have this explanation, and that's for 1 mark there, and then you have to have 3 other points. Next point then, you could say then that that's Faraday's law. The next point then is this causes a current to flow in I. In R, and that causes heat or thermal energy. This energy is converted from the work that you have to do in pushing the magnet into the coil. As the end of the coil becomes a north pole and so repels the magnet. And then the last mark, and this is Lenz's law. This is from Lenz's law. And the last mark then is to say that the work done is equal to the heat produced. And that gets you 4 marks. And you probably haven't got room to state Lenz's law there, but Lenz's law is that the direction of the induced EMF is such to oppose the change it produced, and that's why the end of the coil becomes a north pole. So there's 4 marks. Okay, and then the next question you don't have to do, because it's not in the specification anymore.